going to program OP3, which is the quarter 20 hole, quarter 20 thread on the side of our jaw. See if I can get both of these up there. Already have my work situated so we can get our mind around what we're going to do. First question is, where do I want to put my work coordinate system on my part? It's your decision. So what's going to be the factors of my decision of where I'm going to put it?
The dimensions. There's a dimension on the print.
Okay, the print is dimmed out as, whoops, that ain't it. Come here, you. Wrong side. No, I want you on this side. There we go. So right now the dim is at 3/8 from the top, 3/8 from the side. 0.38 is a weird number. Anybody know why it says 0.38?
Is it rounded up?
It's rounded up from 0.375, correct. And the reason is 0.375 would be a 5-place decimal, and we don't need that type of precision for this feature. So that's why that's a weird number. Okay, so where do you want to put your work coordinate system on this part?
Northwest.
Do you want to put it in a corner? Okay, anybody else want to put it somewhere else? All right, I do. I want to do everything I can to keep from making mistakes. So is there a better way to place my work coordinate system where I won't make a mistake?
In the center of it?
I have 3 tool paths to program where I have to define where I want them to work. So let's just put the work coordinate system where I want the feature. All right? You can put it wherever you want and program away from it if you want to. That's totally cool. But help yourself out. I recommend we put it right there. Right on the, of course we can't see because I don't have the camera up. So for all those people, the home gamers, we're going to put it right there. Good. All right, so we got that figured out, and we've already decided that we are going to use G56. Good. All right, so I've already programmed this. I'm going to pull it up and let you see how I programmed. So I'm going to pull my program up. This is my 725 Kurt instructor copy. CAM, ICN, I'm just going to page down. And notice I just started out, no comments. I've got totally burned out. I'm putting comments in here, especially your guys' comments, where there's like 15 of them in there. I totally get it. But I've now, after this quarter of seeing all this, I'm like, nope. I have drank the Kool-Aid, and I'm simplifying my programs. So what I've done is on block 31, operation 31, I just put G56. I'm an experienced machinist now. I've got 4 quarters of machining under my belt almost. I know that this is an indicator of another operation.
Why do you have a G57 above it?
Why do I have a G57 above it? Because I was much smarter before, and I decided I didn't want to use your guys' work offsets when I was, so I made things more complicated. I should have just said, forget it. I'm going to make these guys' life complicated and just use the exact same work coordinate systems you had. But please, continue to ask questions.
Do you want to change that to 258?
I do not. I am now doing something different than I started because I feel like what I did when I started could have been done better. So this is what I think better is as of today. So the people that get me next year, it's going to be much smoother. All right, so right after we call out our work coordinate system, that means all of our tool paths are going to be in relationship to G56. First thing we want to do is put a new tool in. So our new tool is going to be, let's see if I can get that up here. Oh, yeah. All right, can we get those on there? Yeah, we can almost. So it's going to be that, oh, no focus, huh? It's going to be that spot drill. Manual focus. Boom. It's going to be this spot drill. What tool number did I call it? I called it 6. Why did I call this spot drill tool 6? Because it is the next tool that we're going to use. And that's the numbering convention. Just keep right on going up in the order in which they're used. So remember that when you guys get into your Mastercam and you've butchered that thing all up and you're starting out with tool 5, it gets confusing. So try to program your tool numbers in the order in which they're used.
So for op 2, you did a tool change first, and then you put the...
All right, so the question is, in op 2, I said do a tool change before you change work coordinate systems. And now I'm doing something different. You duplicitous pain in my ass, you. Correct, I am doing something different. And what I have found is, in the way we're doing these assignments, where you come in and you might not be programming op 1, you might not be machining op 1, G54. Well, we're going to try to pull a tool change at that work coordinate system, and it's not there. So it creates problems for us. So that's another thing I've changed. I've decided to change the tool after we initiate the work coordinate system for that op. Okay. I think it's a better procedure, okay, cool. Just from my experience this quarter. So good catch, and I'm changing my mind. All right, now this is an interesting situation here. And the interesting situation is, if I can put that down at the bottom. Whoa, don't want to see too much of the background. So you can just see my part down here. It's that we don't have much room between the spindle and our part. So what I'm going to do here, folks, is I am going to perform a tool change in a location, which we haven't done before. And once again, the reason I'm doing it is because I'm getting some long tools in the spindle, and I want a little more clearance from my part. Okay? On this machine, I've actually lifted the tool check height 3 inches. And then I'm like, forget it, I'm just going to move it off to the side. So, let's do that. So, my first tool change is going to be tool 6. Name it something useful. Please don't skip the description and think you'll come back to it. Whenever you're programming, don't skip something and say you'll come back to it. I guarantee you're going to forget. So if I come and look at your program and there's nothing in there, you're going to get the stink eye. Next, I gave a location to do the tool change. Now here's how I did this. This is going to be something neat. I'm going to give you guys time to write this down. So just watch what I do here. I'm going to see if I can pull the camera up. And what I did is I moved the table over where I wanted to do the tool change. No, your other left, Damon. I moved the table over closer to my tool rack so I'm clear of my work. And I want to put this location in as my location for my tool change. How I do that is I use F9, teach mode. You see this right here? If I press teach, let me go ahead and press it, teach. And it comes up with this information in the bottom of the screen. So I can, at this point, I can grab my X position, my Y position, or my Z position. Now, right now, I have my X highlighted. And all I'm going to do is I'm going to press X on the keyboard. And it grabbed that position and put it in there. So that's what teach does. You can use it for all sorts of different things. It just grabs the position where you're at. And then hit accept. Whoops, I didn't need to get out of that yet. I'm not going to go anywhere in Y because I don't need to, so we're going to stay in Y0. Tool diameter. I'm not putting a tool diameter in. There's nothing wrong with putting a tool diameter in. You just don't need it because we're not going to use this tool axially. I'm sorry, we're not going to use it radially. We're going to use it axially. RPM. We've already decided that the SFM for this tool is 100. So 3.82 times 100 equals 382. Divided by wait a second. Divided. What am I going to divide this thing by? What am I going to divide this by? Wrong one. Wrong one. Where are we going? There it is. What am I going to use for a diameter for programming the RPM on this tool?
201.
201?
Yeah.
Anybody else?
Which is the number 7 drill.
Okay, you jumped at 201 because it's a number 7 drill. Roger that. Does anybody else have another suggestion? All right, here's what I recommend. Remember, we're spotting with this drill. We're going to stay on the conical end of the tool. What diameter is the tool going to experience? Okay? It's a 3/8 tool. I'm spotting for a 1/4 20 hole. Does anybody know what the diameter of the tool is going to experience? All right. So up here in this hole call out, this 201 is talking about my tap drill. This is talking about my thread. And then this bottom line is talking about a countersink diameter 0.28 times 90 degrees. So this is the dim that we're talking about. So I'm going to use 0.28 is my diameter to program this tool, because that's what the cutting edge is going to experience. So that RPM is going to be 1,364. I don't typically like weird numbers like that. However, I'm going to leave it because it looks like I've calculated it and not just pulled it out of my hat. Okay, we're going to turn the spindle clockwise. I do not have mist coolant on this machine, so coolant's going to be off. If you have mist coolant, then go ahead and turn it on. So I'm going to have to use cutting oil on my machine. Actual tool change, yes or no? What do I want to put there?
Yes.
Why? Why do I want to say yes?
Because it'll give you an optional stop.
Correct, because on this machine, that's how I get an op stop. The machine is going to stop for a tool change. So roger that. Then we just hit F10, save.